Hello everyone, and welcome. I'm excited to have you here today. Today, we're diving into the fascinating world of mathematics. This is our opening slide, titled simply Mathematics, and it sets the stage for what's to come. Over the next few minutes, we'll explore some key concepts, applications, and insights that make math so essential and interesting. So, let's get started and enjoy the journey into the world of numbers and ideas. Let's take a quick look at what we'll cover in this section. First, we'll explore integers, which are the foundation of understanding positive and negative numbers. Then, we'll move on to the additive inverse, which is a key concept when working with integers and helps us understand opposites. Next, we'll dive into the addition of integers, focusing on how to add both positive and negative numbers correctly. Finally, we'll look at subtracting integers on the number line, which visually demonstrates how subtraction works with these numbers. Throughout this part of the presentation, you'll see how these concepts connect and build on each other, giving you a solid grasp of working with integers in various situations. Let's take a closer look at integers. Integers are a fundamental concept in mathematics, and they include all the whole numbers, both positive and negative, as well as zero. Think of integers as the numbers you encounter when counting objects, going backward on a number line, or measuring temperature below zero. They are essential because they help us understand and work with quantities that can be added, subtracted, multiplied, or divided within a broad range of real-world situations. Recognizing the importance of integers sets the foundation for exploring more complex number systems later on. So, as we continue, keep in mind that integers are all about the whole numbers and their negatives, which play a crucial role in both math and everyday life. Let's talk about integers today. There are actually many situations in everyday life where we need to use negative numbers. For example, when we talk about temperatures below zero, or when we're dealing with debts or losses. Negative numbers are simply numbers with a minus sign in front of them. They are less than zero, which makes them different from positive numbers. Understanding negative numbers is important because they help us describe and analyze many real-world scenarios more accurately. As we move forward, you'll see how these negative numbers fit into the bigger picture of understanding numbers and their relationships. Let's talk about the ideas of predecessor and successor. When we add one to any natural number, we move to the next number in the sequence. That next number is called the successor of the original number. It's like taking a step forward in counting. Conversely, if we subtract one from any natural number, we go back to the previous number, which is known as the predecessor. These concepts help us understand the relationship between numbers and how counting progresses. They are fundamental for grasping the structure of natural numbers and how each number relates to those before and after it. This idea really ties into the overall theme of understanding how numbers are connected in a logical sequence. Let's take a closer look at what we mean by the definition of integers. Integers are essentially the collection of all whole numbers combined with their negative counterparts. So, when we talk about integers, we're referring to both positive and negative numbers, as well as zero. Now, it's important to note that all positive numbers are called positive integers, and these are numbers like 1, 2, 3, and so on. On the other hand, the negative numbers like -1, -2, -3 are called negative integers. And what about zero? Well, zero is a special case here. It's neither positive nor negative, which makes it unique in this set. Recognizing these distinctions helps us understand how integers form a fundamental part of mathematics and set the stage for more advanced concepts later on. So, in summary, integers include all positive numbers, all negative numbers, and zero. This set is key to understanding how numbers relate to each other in various mathematical contexts, which is a core part of our overall study. Let's take a look at how we can represent integers on a number line. To do this, the first step is to draw a straight line. Once we have our line, we need to identify and mark a specific point on it, which is 0. This 0 point acts as our reference or starting point for all other numbers. From there, we can position other integers to the left or right of 0, depending on whether they are negative or positive. This visual representation helps us understand the relative sizes of numbers and how they relate to each other in a clear, intuitive way. Remember, the number line is a fundamental tool in understanding integers and their relationships within the broader number system. Let's take a moment to explore some facts about integers that are really fundamental to understanding their relationships. First, any positive integer, which means any number greater than 0, is always larger than any negative integer. So, for example, 5 is greater than. This helps us see how positive and negative numbers are ordered on the number line. Next, 0 has a special position. 0 is greater than every negative integer, meaning 0 is larger than -1, -2, and so on. But at the same time, 0 is less than every positive integer, like 1, 2, or 10. 0 acts as a sort of dividing line between positive and negative numbers. It's also important to note that 0 itself isn't part of either the negative or positive integers. It stands alone as neither positive nor negative, which makes it a unique and crucial reference point when we're working with integers. Understanding these facts helps us grasp how integers are ordered and related, which is essential as we move deeper into number concepts and their applications. Let's dive into the addition of integers. When we're adding positive and negative numbers, it's important to remember that we're essentially combining their values while paying attention to their signs. If both numbers are positive, we simply add their magnitudes, and the result stays positive. If both are negative, we add their magnitudes as well, but the result is negative. However, the interesting part comes when we're adding a positive and a negative number. In that case, we find the difference between their absolute values and take the sign of the number with the larger absolute value. This helps us understand how the numbers interact based on their signs, which is fundamental to working with integers. Remember, the key is to look at the signs first, then decide whether to add or subtract their absolute values. This process is crucial because it connects directly to the overall theme of understanding how integers behave in different operations. Mastering this will make all your future math problems involving integers much more manageable. Let's talk about the rules for adding integers. When you're adding two positive integers, it's straightforward. Just add them as you would natural numbers. For example, 6 plus 7 equals 13. Now, when you're adding two negative integers, the process is similar. Add the absolute values first, then attach a negative sign to the result. So, -6 plus -7 equals -13. The trickier part is when you're adding one negative and one positive integer. Here, you subtract the smaller absolute value from the larger one. The sign of the result depends on the sign of the larger absolute value. So, if -6 and +7 are added, since 7 is larger and positive, the answer is +1. Conversely, if 6 and -7 are added, because 7 is larger and negative, the result is -1. These rules are essential because they help us handle integers consistently and correctly. Remember, the key is to focus on the absolute values and then determine the sign based on which integer has the larger magnitude. This understanding connects directly to our broader goal of mastering integer operations confidently. Now let's talk about how to add integers using the number line. When we're adding integers, the number line is a really helpful visual tool. To add a positive integer, we start at 0 and move to the right. For example, if we're adding 3, we move 3 steps to the right from 0. If we're adding a negative integer, like -2, we start at 0 again but move to the left 2 steps. The key concept here is that addition involves movement along the number line. Right for positive numbers, left for negative numbers. When adding two integers, we can think of it as combining these movements. For example, adding 4 and -3 means starting at 0, moving 4 steps to the right, then 3 steps back to the left. This method helps us visualize the process clearly and understand how positive and negative integers interact during addition. It's a simple yet powerful way to see how integers work together on the number line, connecting to our overall goal of mastering integer operations. Let's talk about the additive inverse. The key idea here is that for every number, there's another number that, when added together, equals 0. This is what we call the additive inverse. Think of it like a positive and a negative version of the same number. For example, the additive inverse of 5 is -5, because 5 plus -5 equals 0. Similarly, the additive inverse of -8 is 8. Recognizing these pairs helps us understand how to solve equations and simplify expressions. It's a fundamental concept that connects directly to the idea of opposites and balance in mathematics. By mastering additive inverses, we can better navigate algebraic operations and see how numbers relate to each other in a more intuitive way. Let's talk about the additive inverse. The key idea here is that for any number, there's a corresponding inverse that, when added together, gives you 0. Think of it as the opposite of a number. For example, the additive inverse of 5 is -5, and vice versa. This concept is really important because it helps us understand how to solve equations and work with numbers more flexibly. It's a fundamental part of the broader theme of balancing equations and understanding the structure of numbers. Recognizing these inverse pairs allows us to simplify expressions and solve problems more efficiently. So, in essence, the additive inverse is like a mirror image that cancels out the original number when added together. Let's talk about subtraction of integers on the number line. When we subtract integers, it's helpful to think of moving along the number line in a specific direction. Remember, subtraction can be thought of as adding the opposite. For example, subtracting a positive number means moving to the left, and subtracting a negative number means moving to the right. The number line is a great visual tool for understanding this concept. By starting at the initial number and then moving according to the sign and value of the number you're subtracting, you can see exactly where you land. This approach helps clarify the process and makes solving such problems more intuitive. Keep in mind, mastering subtraction on the number line reinforces your overall understanding of integers and their operations, which is essential as we continue exploring more complex math concepts. Now, let's talk about subtracting integers on the number line. When we subtract integers, it's really helpful to think of it as a movement along the number line. If you recall, addition involved moving to the right, so subtraction involves moving in the opposite direction. For example, if you're subtracting a positive number, you move to the left. Conversely, subtracting a negative number actually means you're moving to the right, because subtracting a negative is like adding. So, understanding this movement along the number line is key to mastering subtraction of integers. It helps make sense of what's happening when you perform these operations, especially when the numbers are negative. This visual approach ties back to the overall theme of understanding integers through number line strategies, making the concept clearer and more intuitive.